Wonderful. Let's start by taking a look at lists, okay? And lists are structures that allow us to store a sorted collection of elements one after the other. Very simple, right? And why is this? It is because let's say that I wanted to store in memory a sequence of numbers. For example, the numbers from 0 to 50 in steps of 5, for example. If I wanted to do that with the techniques that we know so far in this playlist, what I will need to do is I will need to do something similar to, for example, let's say I'm going to declare a variable called number 0. That's going to be 0. Another number called number 1, which is going to be number 5. Then number 2 is going to be 10. And then so on, and end up writing a full list of individual variables that store individual individual digits. So I could use this to now maybe write some of them to the console, but this is very tedious. It requires a lot of typing, and it's not practical because if I now wanted to change, for example, the scale of these numbers, and instead of 5 units of 5, I wanted units of 2 or units of 10, then I would have to manually change each one of the numbers. And if I wanted to add more, to, for example, up to 10, 20, even 100, it would just be impossible to maintain this by typing everything manually. So there has to be a way to declare programmatically, to declare with code, a structure that can hold and maintain all these values one after the other, and that I can access in a more programmatic way. And that is where lists kick in. Okay? So how would we write this in in a different way? Well, lists are like any other variable, are things that you can declare as part of your program. So you can declare a variable, for example, that I'm going to call numbers, and then I can declare that this can be a list of integers. So for example, something that I can do is I can say I'm going to write here the fact that this has to be a list of integer values. Remember that C# is a strongly typed language, and we have to specify the type of everything that we do. So the way we do that is list. We can have lists for any type of data. So the way to specify that the data that this variable is going to contain is integers is by using this angular notation, opening and closing angular brackets. And then, so this is the declaration. And then the way we create a new empty list with no numbers inside of it is by using this particular syntax that we will start understanding more deeply down the road in this playlist, which is a new list of integer values, and I'm going to open and close parentheses here. Okay. As of right now in this course, we don't really know exactly what these angle brackets mean here. Why do I have a new keyword here? Why do I have to open and close parentheses when I declare this object? But I'm going to ask you to trust me on this one at this point, because it will take me a few videos to unfold where all of this is coming from. But the idea is that anytime that I want to create a list of elements, I can do so by defining the variable, defining that it's a list of whatever type is going to be contained here, and then using this same syntax to create that list. Okay? What does this also mean? It also means that because I'm declaring the type that is going to be stored in the list, it follows that lists in C#, this is different in other programming languages, but in C#, lists can only store the same type of data. So if you clear a list of integers, you cannot store strings or doubles or any other type inside of them. You always have to be consistent with the data type that you store on the same list. Then, if this is the case, then at this point we have an empty list of integer numbers. Okay? Now, what can I do to start adding elements to this list? So what I can do is I can say, well, to the variable numbers, if I click dot, then what I'm going to do is I'm going to access a particular set of the properties and the methods that, that lists have available to work with. We also haven't seen this yet, this idea of the dot notation and accessing properties. We've seen similar things with the console object and with the math object, but I will explain actually by the end of this section the idea of classes with methods and properties. Okay? So if I hit dot, I can now scroll down and see all the functionality that is available for lists. All right. So for example, the most important one, probably it's already recommended here by IntelliSense, is adding a list to this element. So I can now click add, open and close parentheses, and then I can just add a new integer element to this list. So for example, 0. And then I can copy and paste this a bunch of times and say like, this is going to be 10, this is going to be 20, this is going to be 30, 40, 50, and 60, and whatever. Okay? Now, what is the next thing that I may want to do with this list? Well, maybe I want to print the values of that list to the console, right? So how about we do that? Let's say console write line, and let's print all these numbers to the console. As I do that, I'm going to hit execute, and the window pops up in my other screen, so I'm just going to put it here, okay? And then something strange happens. What it happens is that I don't really get a printout with all the numbers on my console. And that is strange. What I get is this really strange printout like system collections generic list system integer 32, which I'm not really sure what this means, but it's not what I expected. The idea of what's happening here is that what I have asked the computer to print out to the console is the whole list, is the list variable, okay? And that doesn't mean that I'm asking the computer to print any of the particular elements that are inside of the list. And therefore, because the computer doesn't know what to do with this object that has been passed to it, it basically prints the data type, the full signature of the data type of this object in the console. All right. So that is not exactly what I wanted to do. Probably what I wanted to do was to print out one by one each one of the elements of my list, right? So the way I can access and read each one of the particular elements of my list is by using what's called the square bracket notation to point to a particular element on my list and then print that and then read that value and print it to the console, for example. So let's say that I want to print the first element of my list to the console. Then something that I can do is in here, in numbers, I can open and close square brackets, and then inside of the square brackets, I can input the position of where that object is on the list. So if I want the first object of my list, then I might be inclined to say, let me put here the number 1. And let me show you what's going to happen. If I do number 1 here, the number that prints out is not 0, which is what I expected. That was the first number I added. What I get is the value of 10. This is one of the biggest mistakes or one of the biggest things that it's easier to forget when we're learning how to program. And it is the fact that most computer programming languages start counting element positions with the number 0, not with the number 1. So it turns out that the element that is at position 1 on a list is actually the second element on that list. So if I wanted to actually print the first element, I need to substitute this with the value of 0, okay? And then that's where it just prints the first element of my list, okay? And if I were to print 1, 2, 3, 4, 5, 6, there's 7 elements in my list. If I wanted to print the last one, what I would need, if there's 7 elements, I would need to print the element in position number 6. So that's going to be this one here. Is that clear? Wonderful. Now, square bracket notation is also, before I forget, it's very important that when you are pointing to elements on a list with a position, it's important that you do it right and that you're pointing to an element or a position in a list that actually exists. If this element has 7 elements and I point to element number 7, for example, remember, that would be like 1 over the capacity. What that's going to happen is that I'm going to get an error because I'm out of range. There are not enough elements. Remember that if an element, if a list has 7 elements, the last element of that list is the one in position number 6. So there's no element in position number 7, and therefore my code break. This is one of the most common reasons why beginner code breaks, is because we're trying to access data on a list or an array that doesn't exist. Okay, so let me go back here to number 6 or number 0. Another thing that we can do is we can manually override values on a list. Okay, so for example, I can use the square bracket notation not only to read elements, but I can also use it to, if the element already exists on the list, I can use the square bracket notation to point to that element and change the value. So for example, I have created the list. I have 7 elements in this list. Now what I can say is like the first element that I added, for some reason I don't like it anymore. Let me change that. So I can go ahead and say numbers, the element in position number 0, whatever it was before, I don't care anymore. I'm going to write the value of 2 point something something something. But wait, this gives me an error. Why does it give me an error? Because I am storing numbers in this list. But remember that lists are strongly typed. So if I said that these numbers have to be integers, it's not going to let me store a number with decimal part. So I'm going to substitute this by the number 23, for example. And if I were to print now this list here, you can see that I get the value of number 23. All right. Now let's go back to what we wanted to do at the beginning, which was to print all the elements of this list to the console, one by one after the other. If we know that we have 7 elements on this list, then it turns out that what we could do is like we could do, let's print this, the first one, the second one, the third one, the fourth, fifth one, and the sixth one, right? And I mean, technically that is going to work, but what do we think about these techniques of like copy pasting code and changing numbers? It's not very programmatic, it's not flexible, it's not going to let me, because if I were to now start adding more numbers here, right? 70, 80, 90, whatever, if I were to do that, then now I would have to remember to change the code here and add more lines to print more elements. And if this is one after the other, maybe I can remember. But if these 2 parts of the code are separated by a million lines of code in between, then I'm definitely going to forget. And also, if your list had a million elements instead of just 10, then it would be very tedious to do this. So there has to be a way to print all the elements of the list programmatically. And as you may suspect, we've already seen structures that allow us to perform the same operation over and over again with slight variations. And that operation, those are for loops, for example, or any iterative structure that allows me to perform the same operation over and over. So I'm going to substitute this. I'm going to remove all of this. And what I'm going to do is I'm going to place this inside of a for loop that is going to start at 0. I is going to be less than 7. Okay. And then I is going to be plus plus. And then I'm going to place this here. And inside of the position number, what I'm going to do is, instead of hard coding the number, I'm going to write the variable I in here. So that with this for loop, I'm iterating from the numbers 0 to the number 6, right? Because mine is less than 7. And for each one of those numbers, 0, 1, 2, 3, 4, I'm going to print each element to my list. And then to my console. And then if I do this, now I get a nice printout of all the elements of the array here. All right? How awesome is that? Well, this is great, but you know, I am very stubborn, and I want to make you like really pro computational designers and programmers. So this code is starting to be much better, but it's still not great. It's still not fully programmatic because, again, if somebody were to add more elements to the list, now it just so happens that I would have to remember again to go to that for loop and change the number 7 to whatever, and I would actually have to come here and count how many lines there are, etc. not great. So there needs to be a way, if I want this for loop to always print all the elements that are contained in the list, there has to be a way to figure out programmatically, to figure out with some kind of rule or some kind of technique, always the number of elements available in a list. And it turns out that there is. So if I go to the number 7 and I replace this with numbers dot and I press dot, I start accessing not just the functionality like add, but I can also access properties of the numbers list. And those properties are things that tell me characteristics of what the list is doing or how the list is behaving. And one of them is the word count. And as you can see here, the signature of this count property is that it gives me back an integer value, and it gets the number of elements contained in the list. So if I click here and I say numbers.count, I know that this property, which is kind of like a variable that exists inside of the list, this property is always going to give me a number that represents how many elements are contained in this list. C# takes care of maintaining that. I don't have to do anything with that. C# is the one who makes sure that that number is correct. And then with that, now I can say I'm going to print this. I don't even know how much count it is, but I know that it's the right value to print all these numbers here. And if I now programmatically reduce the amount of elements, I still know that the for loop is going to adjust exactly to the number of elements on my list. So this idea, using a for loop to iterate from 0 to the number of elements in an array -1, so I is less than that value, one at a time, and then use the variables, the values of that list for whatever purpose, for printing them to the console, for creating a geometric object, whatever, is so common that actually very commonly, the reason why the variable name for the variable that we use inside of for loops is typically the variable I, is because this refers to the index number or the index position of elements in a list. For loops and lists are such good friends that they're usually written in tandem very often. And in early computer programming, for loops were basically the structure that was used to manipulate, to store, and to create also lists and arrays of information. Okay, so this is what we use to print all elements to the console. Lastly, something that I want to talk about is the fact that you have heard me like complain so much about writing programmatic code, not copy pasting lines of code. And when we were declaring and we were adding elements to that list, that was also not very programmatic because it was very manual, very handwritten, right? I had copy pasted this line of code 17 times. So if what I wanted was to programmatically create a list of numbers and store them as a list, and there was a logic to the sequence and the order of those numbers. So for example, here we kind of wanted to create a list with numbers at 10 unit intervals, right? So it's very simple to write a rule for that. If there's a rule that we can write, then making this, copy pasting these lines and writing them manually, it's definitely not a programmatic way to do that. And you probably know where I'm going with this. What structure do you think we could use to programmatically populate a list with a lot of values if we know the rule that those values are going to follow? I'm going to give you 2 seconds. Ta-da! Exactly. You probably guessed it. We're going to use a for loop here to populate a list with however many values we want from starting at 0 and at increments of 10 units. So for example, here I'm going to say for int equals 0, I equals 0, I is less than numbers dot count, and then I plus plus, and then I'm going to do this, and I'm going to add here the value of 10 times I. Okay? And if I run this code, I think I'm actually going to get an error, right? Yes, I'm getting an error. This is not working. What did I do wrong here? I very much stress the idea that here we should be able to read programmatically how many elements are in an array in a list, but I don't think that's what I want to do here. It's not what I want to do there because at this point in the life of the program, numbers is empty. Numbers has no number has no elements here. So if I create a loop between I is 0 and count, which is also 0, then this for loop is actually never going to iterate any cycle whatsoever. So when I create elements for a list, that case is a case where I actually may want to hard code here either a number, so I'm going to do here, for example, 25 elements, or where the number of elements that I might be using here might be coming from some other rule in my program, or might be coming from user inputs or from typing in the console. So maybe I can just say like elements is going to be, for example, 25, and then here I'm going to create a for loop where I'm going to iterate elements times and then create that many elements in the array. So now you can see I got my list of data, which is numbers from 0, which I manually overwritten here, to 240 at intervals of 10 units. So using for loops to populate data lists, using for loops to read data from lists, and using for loops to manipulate that data. So for example, I could be doing here, I could write a for loop here that says take each one of these elements and multiply it by 2. Okay? And then the result of that is going to be that they're going to reach almost 500 units. Okay? So the idea of manipulating data with for loops, creating data on lists with for loops and reading it is so important that I don't know if I've told you about like tattooing like cheat sheets on your arm, but probably this is something that you also want to find some space on your arm to tattoo on. For loops as the best friends to create and to read data from lists. Okay. So with this, the only thing that I want to mention as well is that very typically when it comes to lists, because when you declare them, it's a little tedious. You have to type like list and then the type and then the other stuff and then the other type. You will very often see out there in the wild how people, when they declare lists, they use the implicit type operator. And we have a chapter, we have an episode before in this course where I explain what this means. But this is basically a way of like shortcutting, having to define manually what the type is going to be. And then the type becomes implicit by this declaration, this constructor here. When I teach, I like being very explicit about things. So I'm going to leave this with the full type signature here. All right. And with that, I think this is everything that I wanted to explain the basics of lists. If you're interested in more, you can always go to numbers dot and then figure out all the stuff that you can do with lists. So for example, you can add range, which means taking another list and attaching it to this list, therefore concatenating two lists. You can, for example, see how much capacity it has. You can clear the list, so I can just forget whatever it had, just wipe it out. I don't want it anymore. Or you can also use, for example, remove at and type there the position of the element that you want to remove. So I have a long list. I want to remove one element in the middle for some reason. So I can remove the element at position number 5. Okay, so there's a lot of stuff that you can do with lists. They are a very flexible and very mutable structure. It's very it's very nice and very easy to use in C#, and I highly recommend you take a look at, you give it a try, okay? I think in the next video, what I'm going to do is I'm going to explain arrays of data, which are a very similar structure, but it has a few nuances of things that we need to keep in mind. And then in the third video, I will hopefully explain what the difference between lists and arrays are and when to use one or the other. So stay tuned for those videos further down in this course.